Hello and welcome to the second part of this workshop on forces for Physics 190 here at the College of St. Rose. Again, my name is Matthew Woods. I'm Assistant Director of the Academic Support Center here at College of St. Rose. And we're going to continue on with inclined planes. Now before we get too much into this, excuse me, I just wanted to let you know this is actually going to be a three-part presentation. I apologize for that. I just felt like this was starting to get a little bit longer than I was originally planning. So by breaking it up a little bit, it's easier for you to follow. So this second part is just going to be the stuff on inclined planes up through the next, let's see, that'd be 1, 2, 3 slides. I know that sounds pretty short, but I want to save a full presentation for the last part. Alright, so this is just going to be the next few slides in that presentation. It's the same packet that you used for the first part. We're just picking up where it says inclined planes. Alright. So a man's pushing a 30-kilogram block up an inclined plane, which has a 30-degree elevation from the surface. Determine the force the man needs to apply to the block in order to give it a constant velocity if there is no friction on the ramp. The process for doing these problems is going to stay the same. No matter what we change, the inherent process is going to be the same. Still drawing free body diagrams, still labeling the forces, labeling the axes. The only difference when you're on an inclined plane is that one or more of the forces need to be broken into components. That means that they're going to be in more than one direction. And we're going to keep it simple. The axes aren't always going to be nice straight up and down like you're used to seeing for like kinematics or like a graph. I'm going to show you how to do it, but basically the x-axis is going to go along with the ramp. And that makes life so much simpler. And if we do this problem right, we should get 147.15 newtons. Alright, so let's see how to do it. Well, like I said, the process is going to be the same as before. So we've got, the only difference now is that we have a ramp. So there's my ramp. Here's my 30-kilogram block. And my applied force is going to be in that direction. So that's my x direction. 90 degrees counterclockwise to it is the y. Now let's draw on the rest of the forces here. I know I don't have friction. I do have to have weight. Weight always acts straight down. No matter the direction of the ramp, the weight always acts straight down. Then I've got the normal force. The normal force always has to be perpendicular to the surface that you're on. Alright, the word normal, in physics at least, means perpendicular. Now look at this. I've got my normal force in the y direction completely, and I've got my applied force in the x direction completely. I only have one force that breaks into components. If I kept these axes the traditional way, everything would have to be broken up. Now I only have one thing that needs to be broken up. That's so much easier. So here's how we have to break up the weight. And this is the weight in the y direction. This is the weight in the x direction. Alright, the normal force is going to be our positive y. So these are all negative. Something I forgot to do earlier. Let me just do it now. Finish drawing in the ramp and labeling it as 30 degrees. Now, in order to figure out what these two are, we need to know the angle that's right here. And it's really simple. This triangle that I've traced in here and the triangle that's formed with the ramp are similar. That means that this angle is also going to be 30 degrees. Now I just need to remember my trig functions. Well, I know weight is just mg. This, weight in the y direction, is adjacent to that 30 degrees. So to find it, I take the mg, and I'm going to multiply it by the cosine of 30 degrees. Why cosine? It's adjacent to the 30-degree angle. The weight in the x direction is going to be mg sine 30 because it's opposite the 30 degrees. You got to remember SOHCAHTOA. We know the hypotenuse is going to be mg. This line here is adjacent to that 30 degrees. Cosine adjacent hypotenuse. This part here is going to be sine 30 because we have the opposite in the hypotenuse. And all of these are going to be negative. So those are the only forces acting on the block. Let's chart what forces we've got. So we have the microphone cord's not reaching that far. Okay, so we have F in the x direction, F in the y direction. In the x direction we have FA, which is what we're looking for. And we have the part of the weight that's in the x direction, minus mg sine 30. I'm going to make life really simple for you guys. If there is no friction and the block is not bouncing up and down on the ramp, you can ignore the y direction. I'm going to say this one more time. If there is no friction and the block is not bouncing up and down on the ramp, you can ignore the y direction, as long if there is no acceleration. Which there will be no acceleration in the y direction if you've set your axes up correctly so that the y direction goes exactly with the normal force and the block is not bouncing up and down. Alright, so again, if the block is not bouncing and there is no friction, we can ignore the y direction. So that means, I'm going to just bring this all down here, x minus mg sine 30 equals mass times acceleration. Now, what do we know from the problem about the acceleration? Well, again, it says constant velocity. That means acceleration is 0. So this whole thing becomes 0. X minus mg sine 30 equals 0. I can just bring this over to here by adding it. So I get x equals mg sine 30. Now I know everything over here. I know the sine of 30, I know g, I know m. I can calculate x, and I get 147.15. Try it out. Mass we know is 30. G we know is 9.81. Multiply those two together. Then multiply that value by the sine of 30. If you're not getting the correct answer, chances are your calculator is not in degree mode. You have to make sure that whatever calculator you're using is in degrees. If it's in degrees, then you'll be able to get this problem right. Otherwise, it's probably in radians mode, and the sine of 30 changes. Sines and cosines change between degree and radians. One's in terms of pi, the other's in terms of 180 degrees. Remember, if at any point during the presentation you have a question, send me an email with the name of the workshop in the subject heading, and I will get back to you as soon as I can. Alright, we're going to kick things up a notch. Same setup as before, but what's the difference? The difference now is that we have friction. Alright, I didn't want to throw a friction one at you this time without doing one together. So if we do it right, what's the answer going to be? If we do it right, we should get 198.12. So let's see how to do it. It's going to be the same drawing as before with one little change. Same ramp. Still 30 degrees. Still got my block here. That's 30 kigs. Still have the weight going straight down. Still have the normal force like that. Still have my applied force like that. So that's my X and that's my Y. Now here's the difference. I now have a force of friction. Acceleration's still 0. And I still have to break up my weight. This is always going to be the same angle as the ramp. Just think of it as you're taking the ramp and twisting it so that the triangles overlap. It's still going to be 30 degrees. This is still mg cos 30, and this is still negative mg sine 30. Alright, looks like we've got everything labeled now. Now, because we have friction, we do need to worry about what's in the y direction. I'm going to show you why. Get it? Show you why. We have to use the y. FA is what we're looking for still. That's going to be x. I have minus mg sine 30. While I'm thinking of it, this is one of the things that people get tripped up on, is that in kinematics, usually when you're talking about the x direction, it's cosine. But in forces, a lot of the time it's going to be sine. You have to remember what direction you're in and how your triangle lies. Here, this is opposite the angle. Remember, weight works mostly in the y direction. So the x is the opposite of y, so you have to use sine. Now I also have force of friction. And the force of friction is the coefficient of friction times the normal force. And this right here is why we need to use the y direction. But that's pretty straightforward though. Normal force, and we have minus mg cos 30. If I were to sum these up, I get F minus mg cos 30 equals ma. Well, I know the acceleration is 0. Acceleration of y usually is 0. So I have F equals, Fn equals mg cos 30. This value here, I can plug into there. So I will get x from the applied force minus mg sine 30 from the weight minus mu times mg cos 30, which equals mass times acceleration. I know this is going to be 0 again, because it says the acceleration is 0. So I'm going to get x, and I can bring both the weight and the friction over to the other side. Mg sine 30 plus mu mg cosine 30. Now I know everything on the right side of the equation. I can just plug and chug it into a calculator. And if you do it right, and your calculator is in degrees, you will get 198.0 0.12. All right, this next one you're going to do on your own. A man is pushing a 15-kilogram block up an inclined plane, which has a 45-degree elevation from the surface. Determine the force the man needs to apply to the block in order to give it a constant velocity if the coefficient of friction between the block and the ramp is 0.4. So I invite you to please pause the video and do the workout. Unpause it to find your answer. You should get 145.67 newtons. All right, that's going to conclude the second part of this three-part presentation on forces. I thank you for your time and look forward to seeing you in part 3. Goodbye.